All right, so we've been talking about mathematical expressions. Some are just simply numeric. That means they don't have any symbols or any variables included in them. Or some are a combination of symbolic and numeric. Or actually, we can even have some that are completely symbolic, but we haven't looked at any of those yet. We'll save that for another lesson. Let's take a look at what an expression that is made up of multiple terms. Now, if that vocabulary word sounds unfamiliar to you, jot it down in your vocabulary section of your notes, and then take a look at this example here. So we have 3x plus 5x minus 2. Now we have here, you can kind of tell it's like this is an expression, this is an expression, and this is an expression. This is actually what we would call an expression of 3 terms. And we divide terms by addition and subtraction signs. So this is one term because there's an addition sign that divides it from the next, or I shouldn't say divides, separates it from the next term. 5x is a term because it's separated from the next part by a subtraction sign, and then 2 is the final term. It doesn't have a symbol, but it still counts as a term. So this is an expression that involves 3 terms. So we're gonna get rid of those for a second. And we want to talk about what it means to simplify an expression by combining like terms. Let me write that over here. What does it mean to combine like terms? And most simply, that means that we're looking for expressions that are similar according to their variable. So for instance, right here I have a term that involves an x. I also have a term here that involves an x. And here I have a term that is numeric only. So I'll just put a pound sign to mean number. That doesn't mean hashtag here, it means number. Okay, so we have 3x plus 5x minus 2. So which expressions here are similar? Which ones are like each other? Well, actually 3x and 5x are like each other. And actually, if we think about our definitions that we just created before, we know that 3x means just x plus x plus x, right? And we know that using the same definition, 5x is x plus x plus x plus x plus x. So there are 5 x's. 3x is 3 x's, 5x is 5 x's. Because these are like terms, we can simplify this and call this just 8 x's. So why call it 3x plus 5x when I can make it simpler by calling it just 8x? Now the minus 2 is unrelated, so we just have to leave it here. It is unlike the others. It doesn't have anything to do with x, so it has to stay alone. So 3x plus 5x minus 2 simplifies, using combining like terms, it simplifies to 8x minus 2. Okay, that's example 1. Let's look at a second example. I'm going to clear this screen here. Don't save. Do something new. All right, let's look at the example of x squared plus 2x squared plus 3x plus 5. So looking at this, I can tell right off the bat that we have a total of 4 terms. 1, 2, 3, 4 terms. And I know that those are separate terms because they're separated from one another using either an addition or a subtraction sign. We don't want to leave that there, but that helps us to visualize there are 4 terms. The question I want to ask myself is, are there any like terms? That means, do I have any that kind of, they look the same? So right here I have a term that involves x squared, and it's important that I don't just call this an x, I call it an x squared. An x and an x squared are 2 completely different mathematical pieces of information. So I want to label the first as a term that involves x squared. I label the second one another term that involves x squared. The third term involves x, and the final term it's numeric. It doesn't have any x's involved. So which ones can I combine? Which ones can I simplify? Can I pull together? Well, the first and the second term both have to do with x squared. So can I put them together? Let's think about that. Well, what does x squared mean? Well, it just means, we'll just say just x squared. I mean, it does mean x times x, but we're not going to write that all the way out. What does 2x squared mean? Well, it means that I have two x squareds, x squared plus x squared. So if I were to take these two terms and try to write them as one, how many x squareds do I have? X squared plus 2x squared, well, I have 3. I have 3 x squareds. 1 x squared in the first term, 2 x squareds in the second term, so if I add them together, I should probably take that out so it doesn't look like a subtraction sign. If I add them together, I get 3 x squareds. Now I can't do anything, I can't combine that with 3 x's, because an x is a totally different type of mathematical expression. It has nothing to do with an x squared. And I can't simplify our plain old number down here, 5. So 1x squared plus 2x squared plus 3x plus 5 simplifies to 3x squared plus 3x plus 5. Now, one of the biggest mistakes that I see happen with this type of problem, and I'm gonna keep you looking at the screen here for a moment, not my face, because I want you to look at this. Let me just kind of put a box around it. Draw our attention here. The biggest mistake I see happen in this type of problem is people trying to oversimplify. The idea that we have to somehow make this all squeezed down into one term. Like maybe they just say, oh, well, 3x squared and 3x, I can put that together. I can make that 6x squared, or maybe cubed, right? An x squared and an x. No, we can't do that, because this type of term is an x squared term. This type of term is an x term. We can't rename them by just squishing them all together. You have to keep each term in its own category. And what I mean by that is x squared, x, simple numeric. Don't try to oversimplify. It's okay to leave it as several terms. That really is completely acceptable and actually completely correct. That's how we would simplify this. All right, let's start. I'm going to erase this just to give us a clear board, and I'm going to rewrite this expression one more time. So we're going to